Hello, everyone. Good morning, good afternoon, good evening. Very warm welcome to our webinar, IoT Security Issues and MQTT. I am Jayashree Hegde, moderating this webinar. My team and I are super excited about this session. So today's session is presented by Gaurav Suman, Director of Product Marketing at HiveMQ, joined by Gaurav is Florian Raschbichler, who is Head of Support. He will be supporting us with Q&A. Very warm welcome to you, Gaurav and Florian. Thank you for joining us today. And before we kick off this session, I would like to share that this webinar is being recorded and it will be shared over a follow-up email. And there will be a dedicated Q&A at the end of the presentation. If you have any questions during the session, please submit them in the Q&A pod in the control panel. If there are any unanswered questions, you can always reach out to us in the community forum. Lastly, I request you all to participate in the polls that we will run at the end of the session. So without further ado, I will hand it over to Gaurav. The stage is yours. So welcome, everyone.
Excellent. Thank you, Jayashree. Greatly appreciate it. Thank you, everybody. Thanks for joining. I'm very excited for the topic and excited for all of you to be present here. I'm sure there's going to be some great conversations. We absolutely must benefit from Florian's presence here, and he's obviously been a voice in the IoT space for a long time now. And as we go on along, Florian, please keep chiming in where you feel necessary. And of course, in the end, we'll use your expertise also in the Q&A section. So thank you, everybody. Thanks for joining. My name is Gaurav. As Jayashree mentioned, I lead product marketing here at HiveMQ. And what we are talking about here today is IoT security and the role that MQTT can play in securing your IoT estate. So let's begin with why IoT security is top of mind for developers and for architects. In the latest report from research firm IoT Analytics, we are seeing that there is a trending towards approximately 27 billion connected devices by the end of 2025. Now, you may have seen a bigger number in the past, but let me qualify this a little bit. As we all know, there's an ongoing chip shortage, and that means the trending has been modified slightly, but it's still a massively large number. And also, reality is that not a week goes by without hearing about a news of a pacemaker getting hacked or somebody showing off how they can hack into a connected vehicle. The attacks that happened late in 2021 on some of the utility companies in the US also showed us how vulnerable the infrastructure is. And the list is long. There are nanny cams getting hacked, and this list is pretty long. So the risks are pretty clear. But one has to wonder, right? Why is it hard to implement good security on an IoT setup, particularly in an IoT setup? So the challenges in IoT security are unique. You have typically devices which are low power and mostly running on batteries. These are devices which are far out in the field somewhere, and usually not behind a multi-tier physical security system of some kind, which is to say that it's not protected by protected from, I should say, from bad actors from a physical access. So, we are talking about, say, a connected bike or an IoT sensor in a remote area, which can be physically broken into by somebody, right? Tampered with. You can reverse engineer, try and figure out some potentially harmful information. You do it to a few number of devices, and then you are beginning to create replicas, and you are trying to break into the larger IoT system, spoofing and pretending to be somebody else. And all this is a risk because the devices are, again, far out in the field. And how about the fact that many of these devices, they have a very long life cycle. So a car which is leaving the factory, getting into the world, is expected to be out there for 10, 15 years, typically. So how do you keep it secure? How do you keep the software, the technology on that device updated? And it's not always possible to just bring them in and do a firmware update. So this is what you need to be thinking about around building a security infrastructure, which is in essence out of your hands and is going to be out there for a long time. So before we dive deeper into this conversation, I want to show you who we are and why it's a good idea to hear our point of view when it comes to IoT security. We are HiveMQ, and we are serving nearly 150 customers across continents and multiple use cases. And security is one of the key pillars of our platform. We are securing IoT data end to end, and we offer a full toolkit to make sure that you are able to implement your security profile and posture with full flexibility and full confidence. We'll talk a little bit about that later in the presentation. There's many things which are default built in out of the box. And then there's the enterprise security extension. We'll talk about that later in the presentation here. And that's where you'll see how you can get very deep control and flexibility on your security architecture. And really, everybody perhaps here joining today has a sense that and security is just not a switch that you flip on or off. It's just not a feature. It's a strategy. It's a mindset. It's something that needs to reflect on multiple layers of your setup. It's the policies and practice that you create and adopt on the enterprise level. It's the security that you maintain on the network itself. It's the security of the hosts that you're using, whether it be a public cloud or a bare metal server, a virtualized server, etc. And of course, how the applications and the data linked or within those applications, how that is protected. I really love this quote from the 34th President of the United States, Dwight Eisenhower, where he says, hey, we'll end up bankrupting ourselves in the vain search for absolute security. This was obviously said in a certain context, but it's work, but there's no choice really, right? And there's a balance we need to strike between going too far and in the process compromising on the flexibility, form, and function of our applications versus the security controls that we put into place. We'll talk about that a little bit as we go on along here. Let's zoom into the application security, right? Because this is where MQTT applications live. And I encourage you to look at the stack on the left, right? The typical TCP/IP stack. There's network, transport, and applications layer. And we'll talk about how the security needs vary at each of these layers from an IoT connectivity perspective. So at the network layer, a typical threat you have is of unauthorized access, denial of service, man in the middle, replay, etc. And a possible remedy is to implement an end-to-end VPN and secure the connection. Absolutely, where possible, absolutely, you must do that. A layer above that, on the transport layer itself, the risks are more around eavesdropping and replay again, and again, man in the middle attack. And that's because you may have secured the network resource, but the transport connections are still vulnerable to attacks. And a level above, on the application level, your services could suffer again a denial of service attack by repeated unauthorized access requests. And what you need then is a comprehensive authorization and authentication mechanism which can help you manage those challenges, right? But what's so special about MQTT? I mean, so far we are talking about securing IoT, and we are talking about MQTT in this webinar. So what's really so special about MQTT? So MQTT is made for the Internet of Things, right? This is where the extreme scale and the instant, fast, real-time data exchange between devices and things becomes critical. And the architecture of MQTT is a pub/sub architecture. It's not a push-pull architecture. And we'll see in a little bit here how this is helping push much of the complexity on the server side and not on the clients. And we spoke about that before, that the clients are out there, they are vulnerable, they are low on power and things along those lines. So we'll look into that a little more in a few minutes here. So it's a protocol which is built for reliable communication, but over unreliable channels. But you know what I find interesting? I find we talked about the multiple use cases where MQTT is deployed, but I just wanted to get to this, which is what the specification says. The specification specifies, this is the actual MQTT specification, I'm quoting from there, that the solutions are deployed in a hostile communications environment, right? And in that environment is where you are required to provide mechanisms for authentication, authorization, integrity of data, and privacy. Now, this means that the specification has to have many facets, which have to cover authentication through, and we look at those tools client ID, username, password, etc. And then they are also recommending some controls on access to the data itself. But what you see here is, portion of that specification, and a specification is just that. It's a specification. It's not a solution. You need to now look for a solution which says, okay, MQTT specifies here is what it will take to secure your IoT deployment. And now you have to go look for the solution. And when you understand the specification more, you realize that there is an MQTT broker which has to sit in the middle of all the action. And the beauty of this architecture is that the broker does all of the heavy lifting on its end, so the clients can be lightweight. Right? So on a high level, what the broker is doing, which is the HiveMQ platform for the sake of our conversation at this point in time, it's decoupling the open and the public untrusted environment from a secure backend here. Right? That's the decoupling it's creating for your applications. What it also does, it helps conserve bandwidth and resources. Now, for example, it can reuse X509 certificates for application level security. It's meant to be for transport level security, but we can also use it on application level security. It can help you implement payload encryption on the broker, where TLS, for example, is not an option. You could do a payload encryption on the broker. You are able to centralize policy control. So you can implement policies on who the subscribers are and who the publishers are, what they're allowed to do. You also get denial of service protection. And essentially, it's helping you keep traffic in its lanes. So I mentioned a few things here which might be new for some of the people attending today. I mentioned TLS, I mentioned X509, I mentioned denial of service, and I'm sure most of you know what these are. But before we go into these, deeper into the controls of IoT security, let's just quickly refresh our memory on a couple of foundational concepts here. So MQTT is based on the TCP/IP stack, right? And it can be secured using TLS. So MQTT over TCP is port 1883. That's what your applications got to be listening in on. And when it's secured with TLS, it's port 8883. A quick aside, by the way, so this is the Brooklyn Bridge. And what's interesting is that 1883 was also the year in which traffic started flowing on the Brooklyn Bridge for the first time. And interestingly enough, it was only 2 days ago that Brooklyn Bridge had its anniversary. So happy birthday, happy 139th birthday, I should say, to the Brooklyn Bridge in New York City. All right, moving on along. Let's now look at how is it that MQTT is helping secure the Internet of Things. So let's imagine a scenario, right? Picture boarding an airplane. You're getting on an international flight and you can afford to forget a few things, but two things you don't or absolutely should not forget. One, your passport. Second, the boarding pass. So think about this. The passport is the one which is authenticating who you are, right? Yes, you are supposed to be at the airport. Here's your passport. They know who you are. And the boarding pass is helping you confirm that you're allowed to access a resource. Now, what's that resource? It's that seat on the airplane, which is going to take you to your destination. Only authentication is not enough. Just the boarding pass won't do. Excuse me, just the passport won't do. And only authorization, just having the boarding pass won't do either, because they both have to work hand in hand. Now, with that in mind, I want to walk you through some more details in an enterprise context. So beginning with authentication, there's many ways to authenticate, and these can all be used in combination. So client ID, username, password, digital certificates, OAuth, and JSON web tokens. Among other things, the choice depends on the capabilities of the client as well. So I mentioned there are clients out there which might be low on power, but there are also clients on, say, a connected car. You have a modern connected car platform. So you have the option to use JSON web token for authentication on that car. So you should. So just depending on the use case, there is an option for you to pick higher tier, more sophisticated authentication options. From an enterprise perspective, relying only on client ID, username, password it's never going to be enough. So we should look at two advanced authentication options here, and these are commonly used, and we'll look into specifics of where they apply and why would you want to choose one over the other. So one option is to use digital certificates. So this is what you will use in a TLS SSL authentication. And the second is that you wire your MQTT broker with a auth store. So there could be a database that you are storing an ACL inside of, or you could plug in the broker into an enterprise LDAP system, and they each have their own benefits and relevance. So let's look at them a little more closely here. In case of authenticating using certificates in TLS, you would rely on a public certificate authority, which is fine, right? You always want to have the latest. You are relying on a third party which has the expertise in managing these certificates. They are ephemeral. They are obviously managed by them in a certain professional level, I should say. But it's perhaps, from an IoT context again, possible that you use, well, I should say perhaps actually, we know customers and we know there are practical implemented use cases where people use also, private certificates, because in a closed loop context, say a shop floor or any closed loop application, there are, it's possible to use a private certificate infrastructure. Now, the benefit, if you do that, the second one around using private certificates is that you're not dependent anymore on a third party, and really you are relying on a third party, hoping that they are more secure and they are the ones who should be giving you the required certificates and the authentication clarity and the confidence that comes with it. But what if that party itself is compromised? That's not in your control. It's outside your control. So in theory, right, the risk that you carry with that is of intrusion and breach into that public certificate authority. And the choice you're making here of using a private certificate setup is going to come with a certain cost. You have to maintain this infrastructure on your end, which means people and resources to manage this rather complex infrastructure, depending on the size and scale of your implementation. But that's just something to keep in mind. Another interesting couple of things I want to be covering here. Hey, Jayshree, can you confirm that you can still hear me? I'm hearing some.
Yes, we can hear you.
Yes.
Okay, thank you, Florian. I'll keep going. Appreciate it. Thank you. And a couple of other considerations when using X509 based authentication. X509 is great. It's a great option when you know who is at the other end, as in, you share a set of security practices with them, and you are expecting the client to send you a valid and usable certificate every time, right? So again, let me go back to the connected cars example. You have configured and coded your client to follow a certain process, right? You made the car, you are the OEM, or you made the platform. So you know what you are going to put in the car in terms of the client code and the certificate information, etc. But imagine if you are not in control of the MQTT client. It's a community created project, an open source project, and you are hosting a public facing broker. And in that case, a digital certificate approach might not be possible, right? So that's something to consider when we are thinking about deploying an X509 based authentication mechanism. And also, managing the certificate lifecycle itself is demanding, and there's many controls that you have to keep in place here. And one of the ones you need to have is what happens if a certificate is leaked. Now, devices which are not supposed to be authenticated might get authenticated. So the way around is to use option one, certification revocation lists, which really is coded on the broker itself. And this is where the broker is going to have to every single time look at the list and decide, okay, am I supposed to authenticate this particular connection request and allow this client in or not? And this, just by the sound of it, I'm sure you can imagine is going to be challenging, because every single time you discover a certificate has been compromised, you have to go in and the broker has to have an updated list. It's going to take time to propagate this to other brokers in your cluster. And also it's going to be difficult to make sure that this happens at a large scale. So other than CRLs, the option people tend to lean on is the online certificate status protocol. So it's OCSP. is the abbreviation. And what's happening here is that you are setting up an HTTP responder server to make sure that the certificates are still valid. So picture this: every time a client wants to connect to a broker, we need to go and check in with an OCSP responder. So this is the client checking in with the OCSP responder, and then they get, yeah, this is good to go. And, and the process kind of moves on. Now, this is again at a scale, right? Think about the scale. It can be expensive when you count the number of calls you need to make to fetch a good, no good response. And it can slow down the system if there are frequent disconnections or a high number of, clients in the picture here. And think about the scenario when the OCSP responder is offline, or let's say it's overwhelmed. Now, what should happen next? Do you want to deny connections? Do you want to say, okay, I know the OCSP responder is overwhelmed, or probably it's overwhelmed, so we can't authenticate. So should we let the client in? And if yes, then obviously you created a problem for yourself. But if you deny it, you're denying it. What are you doing next? Are you going to declare an attack and begin to implement and launch those fail safes that, 500 clients were trying to connect to us, we couldn't authenticate any of them, and they might be still valid clients, but the OCSP responder is the bottleneck, which is not letting you authenticate enough of those. And now there's a bit of a false alarm situation, and that's just going to domino into something more serious and severe. So that's something to keep in mind. And fortunately, there's a solution for the OCSP situation. I explained to you. So HiveMQ Broker supports what's called OCSP stapling. And in an OCSP stapling example, and let me just use a real life scenario here. So there's a connected car platform, and there's 1 million cars on the street, and they are all plugged into a certain availability zone of a cloud provider. Now there's a brief outage, right? The couple of minutes, the availability zone goes down, but then it comes back up. And assuming that there's a nice distributed architecture, everything else is running smoothly. But the one thing which now will come in the way is that these 1 million cars have to re-authenticate before they can connect back to the platform. So everything is running, resources are available, but the bottleneck now was the ability to authenticate. So what OCSP stapling does here is, as you can see, HiveMQ is caching the certificate. And then and these are all configurable options. It's helping offload from the OCSP responder this issue of authenticating all of these many thousands, perhaps million devices trying to connect back, right? Now, what does this look like to you? Does this look like a scalability issue, or does this sound like a security issue? But I mean, really, there's this whole workflow that you need to keep in mind here, right? We are talking about a security issue, but it's becoming a scalability issue. We are talking about the ability to authenticate clients, but then how fast, how well, how confidently you can do that impacts the scale at which you can operate, right? So, something to think about, right? I encourage you to think about this full workflow and the vulnerabilities at multiple levels, including authentication. So I know we are spending quite a bit of time here looking at authentication because it's key, and no pun intended. It's really what's letting you into the infrastructure, and HiveMQ has many, specific features to offer here, including, say, using X509 to authenticate the parties on the application layer also. So moving on to the second option from an authentication perspective, we were talking about certificates so far, and in the second authentication option we talked about, which is where you wire the MQTT broker with an auth store. Let's look at that one now. And this is where we are plugging into an external authentication system, right? So when would you use this? So you would use this usually when the client is not in your complete control. You want to have the flexibility in your deployment without compromising security. And remember, we are constantly trying to balance functionality and security. We don't want to overwhelm the setup with too many controls and slow things down, but at the same time, we want to keep our security intact. So in this option, for HiveMQ, the broker calls the extensions at runtime, which have what's called a callback interface. These interfaces will help you plug into events happening inside the broker. And that helps open up a whole world of possibilities where you can create customized authentication mechanisms. So look at this example here, where we have a callback happening from a callback registry. And this particular parameter here, the client credentials data parameter, is what contains all the data that HiveMQ has gathered from the connecting client, right? The username, password, certificate, etc. And where it gets interesting is that even if the authentication returns a false value, it says, hey, no, didn't pass. The broker has the option to check other extensions. It can go and check into, say, LDAP or another place and still request authentication, right? So you're keeping your setup secure, but keeping that flexibility around, okay, this default authentication did not work, or the primary authentication mechanism didn't work, but let's check another way. And now that you're letting them in through the second option, you can really push this logic further. The flexibility of this is that then you can choose, okay, because it didn't authenticate from the primary authentication logic, I'm going to let them in and then decide what you want to let them do, right? That's a degree of authorization that you can also begin to bring in. So based on a customized authentication logic, you can choose what kind of authorization you give them onto the resources. Speaking of authorization, let's look at that now. That's the boarding pass, which is going to get you to your seat. So you can get to your destination on the airplane, right? The only way to get data in and out of a broker is via topics. A client has to read from a topic, has to write to a topic, and a client can publish to a topic and subscribe to topics. And as a default, they can publish and subscribe to all topics. And that's obviously not what you want. You don't want all clients and all topics, sharing information without control. So what you can specify on the client is, where they can publish, right? Which QoS level can they publish on? So QoS level 012, if you read about it, you will find out, some of these are exactly once writes, at a minimum once transmission and things along those lines, but you can specify what writes any particular client will have and the operations that they can do around read, write, etc. So as an example, you want to give one client the permission to publish on this particular topic, or they can perhaps be listening in onto only one topic. Now, by the way of going back to the idea of ease and simplicity and balancing that with security, remember, we are not trying to come in the way of functionality here. We want the client to behave as we expect it to behave. Now, which requires that the client needs to know, hey, what am I allowed to do? What am I supposed to do? So the controls available within MQTT allow you to find out, right? You're sending a request and you get response back. So what are you allowed to do? What QoS are you allowed to publish on, and things along those lines. So again, it's a very fine, a well implemented balance between functionality and flexibility here. So MQTT is well rounded in that sense to make sure things keep talking to each other in a secure fashion. Excuse me. Let's talk about a scenario here, which I find interesting. What happens if somebody is trying to push data into a topic that they're not supposed to, or perhaps using some parameters that they're not supposed to? Now, you could do one of two things. You can give them a bit of a rap on the wrist and say, disconnect. You're being irresponsible. We don't want more from you, and you disconnect them, and that's done. But what you would also do, based on again the business logic, is give them an acknowledgement and say, we heard you, but then don't pass along that data from the broker to those subscribers down the line. It's obviously a business logic driven decision, but that flexibility exists where you don't worry about telling the clients what we are doing with what you're sending us. You're saying, okay, we got this. And then from that point on, you can just, not worry about that and not pass it on along. So just interesting options available to you from an overall implementation perspective. Also, from an admin point of view, you can use ACLs and role-based access control to make sure that you have control on access to the data. For example, the enterprise security extension, and we'll look at that in a bit here. It gives you the ability to use permissions, which can be stored on a SQL database somewhere to say, hey, this client has to go fetch permissions and find out what it is allowed to publish, right? It's something which can be done via role-based access control and saving ACLs on a database. So let's briefly look at encryption now. We looked at authentication, authorization, and let's cover encryption. Now, as a best practice, you always want to be using the latest version of TLS and latest cipher suites, of course. But the other thing I spoke to you about early on when we looked at the stack was payload encryption. So when TLS is not possible, when you cannot encrypt the whole thing, as in the metadata and the payload, you should consider encrypting at least the payload. And in case you're wondering why would anybody do that, right? It's not safe. Yes, I mean it's a compromise. And what we are talking about here is very constrained devices which cannot afford a TLS handshake, a TLS connection. They have the option to be shipped with a shared secret. And all of this means that it's a very closed ecosystem. Now, remember, if somebody taps into it, if somebody eavesdrops, they can understand what topics you have. They can find out more information around, for example, if it's MQTT 5, you can find out from response codes, what's really going on in this setup. So that metadata is getting leaked, but it's better than not having any encryption at all. So what's the big difference here? I mentioned a few things, but just think about this. If you have a situation and there's a client we have who manages some remote infrastructure, and turns out that their cloud provider, who they happen to use before us, they just didn't have the option. The devices are so lightweight in terms of processing power and memory, they cannot afford to have a TLS encryption running on those devices. So they had to turn it off. And the moment they turned it off, the hypercloud said, no, if TLS is turned off, we can't bring you in. So what they needed was a private setup, which is where HiveMQ provides a self-managed infrastructure. So now in their private setup, again, I'm qualifying this, in their private restricted setup, they have TLS turned off and they're encrypting simply their payload. So it's possible, but the trade-off, of course, you have to make is between securing the full thing or just the payload here. All right, so some other features factors to keep in mind rather on denial of service on your IoT estate. So the setup can be overwhelmed with many things, including, for example, extra long topic length. Somebody is trying to publish on a topic which is super long. The client IDs become hard to manage because they are weirdly the mnemonics people are choosing are going beyond reasonable, I should say. And these are the kind of things which can create malfunction over time. This is what can cause performance issues. If somebody is coming in with a malintention, they could try and create extra connections with you, try and overload some of the clients to publish more than they should be. And these are all things which should be and can be controlled by features on the MQTT broker. So you could throttle the connection rates. You could limit these number of connections and how long can they stay idle without any traffic and things along those lines. So these are factors to keep in mind and make sure that you are able to build those best practices into your setup to make sure you're not left overwhelmed, your MQTT broker and that IoT setup is not left overwhelmed with traffic. Right, so we looked at layers of IoT connectivity and several key factors to consider in authentication, authorization, encryption, overload protection, just securing that whole IoT stack, which I showed you before. And all of this really depends massively on the broker that you keep in mind. Rather, I should say, the broker that you implement at the middle of your IoT setup. So there's a few criteria we recommend you keep in mind when you're looking at your options. So the broker should be performant, scalable, should be highly available. So should be cluster friendly. It should comply with the entire MQTT specification. So MQTT 3 and 5 should allow you to monitor and trace, should have a pluggable authentication and authorization system, as I showed you before, gives you flexibility, gives you the option to bring in clients which are not using a certification-based mechanism, supports TLS, overload protection, and has professional support available to help you make the most out of your IoT deployment. And from a HiveMQ perspective, in particular, our security architecture, and we talked about a few of these things today, it's fine-grained. You can chain many of the authentication mechanisms. We looked at an example of that. Plus, there are some best practices already built in, and we've been doing this for a significantly long time now. Interestingly, today is our 10th anniversary in business. So over time, working with our clients and bringing in the best practices from all over, we have made sure that we are implementing the best of breed security controls in our setup. Part of which is what's built into the HiveMQ security extension, the HiveMQ enterprise security extension, which is where you get central management for authentication and authorization. You can integrate with other systems like LDAP, OAuth, thwart, etc. We maintain a very deep and comprehensive access log, and the concept of whitelisting clients is a default in here. And there's many other controls. That's why I'm sure we are not set up today to have a deep dive into specifically the enterprise security extension, but there's a lot of good that we have built into this security extension, and that flexibility is obviously what enterprises need. So before I open up for questions, just wanted to point out a few resources. We have the MQTT Get Started Guide. We have basics around MQTT security, all on our website, free resources. So we welcome you to read and learn more about the technology. We also invite you to evaluate HiveMQ Cloud or the broker. You can also, there are links here to read more about the enterprise security extension in particular. As a supplement to the conversation we are having today, I absolutely encourage you to watch this webinar, which my colleague and our head of product development, Georg, and our product manager, Maggie, has done, I believe about a year ago, on the 5 pillars of IT security. So that's where you can learn more about the best practices and how this fits into the confidentiality, integrity, and other facets of IT security overall. So that's a great one to check out. So that said, I will turn this back to Jayashree, and we can have some questions now.
Yeah, thanks, Gaurav. It was a wonderful presentation. So we can start the Q&A. Before starting the Q&A, I will launch a poll. I request you all to participate. The polls will be there up till the end of the session. And parallelly, Florian and Gaurav, you can start the Q&A.
Excellent, thank you. So I haven't been looking at the Q&A panel. Florian, is there something in particular which we should tackle first?
I've already went ahead and answered a few of the questions during the session.
Okay, excellent.
We have one question here from John Dumay, who is asking if the use of certificate pinning would be a possible remedy. I believe this was in context to the challenges around certificate management that you described.
Yeah.
My answer to that is in a way, right? So certificate pinning, as it is known from from a web server, from an HTTP connection, is not something, at least that HiveMQ implements, but we have a very similar concept, which is the so-called trust store in Java. So since HiveMQ is a Java application, we utilize custom trust stores can be utilized, and then you would only add the trusted authorities into that trust store, and with this manner, you can avoid the use of trusted CAs. Additionally, other features or functionality of certificate pinning can also be utilized on application level with HiveMQ. So, for example, you can limit the TLS version used, or you could also limit certain cipher suits if your security department, for example, deems certain cipher suits as not secure enough anymore. And then you get a very similar effect than you would have from pinning certificates on an HTTP server.
Right. And I see a question from Jan Schiffer, and they're asking if it makes sense to combine multiple approaches, having a certificate-based security on the TLS layer and then top of that OAuth token security. So the answer, I believe, is yes. Florian, can you help add some color to it just based on specific implementations we've seen with our customers?
Yeah, that's a great question. And yeah, the short answer is definitely yes. Right, and also I like the approach that Jan mentions here. So using the TLS certificate as a means of encryption is, it's a very good approach. It prevents eavesdropping, or that someone gets to the contents of your packets. And if you use it for solely that purpose, the challenges that you described, Gaurav, as the authentication part of the TLS, if you remove that, then it makes it easier and less error prone to manage the certificates. And that's where something like OAuth comes into play, where you have a system that is specifically designed to be centrally managed, having configurable durations of these tokens, where you can then have a fresh authentication based on the token for additional connections. So to go high level again, a little more abstract, yes, it absolutely makes sense, in my opinion, to use TLS for the transport encryption, but then on the application layer for authentication, add additional mechanisms where OAuth could be one of them.
Thank you, Florian. There's a comment on OCSP stabling in particular, and the essence of the question is how many authentications per second is a single server capable of? This is, as I explained, and Francois, this I appreciate the larger context you've given here. But what I was explaining was that the responsibility is getting offloaded to the broker now. So it becomes a factor of how many connections the broker can take, and that number is in millions. So that's the advantage of just offloading that responsibility onto the broker, and the higher capacity you want to build in, just based on the number of devices you have operating, the number of connections you expect to have on the broker. That's what drives this. If we have to give a typical number, Florian, what would you say?
Yeah, so I typed a bit of a more extensive answer in the chat actually to this question.
Oh, okay.
It depends on multiple factors,
Sure.
such as, for example, what's the load on the broker? What else is the broker doing, right? How many CPUs do you have? But a realistic number is here, 500 per second and more. You can even get into the thousands. And it's also important to note, when we talk about HiveMQ, what is for the device a logical single MQTT broker in reality is a cluster of multiple machines. So if you can say, okay, I can do 500 per second per machine, maybe I have 8 machines, then you will add, for example, end up at 4,000 per second that the whole system can handle.
Right. Sounds good. And then we just got a question from Yatin, and Yatin is asking, how is MQTT 5 differing in terms of security from MQTT 3? So Yatin, I encourage you to absolutely read more on our website. We have an MQTT 5 essential series, but briefly here, MQTT 5 adds enhanced authentication options, and you can have a control on the authentication method, some of the examples we covered today are actually from MQTT 5. So it's in particular, the advanced authentication option is, which we did cover in the presentation today. I'm just checking at the specific terminology here, which is skipping me at this moment.
I'm happy to jump in, Gaurav.
Yes, please, Florian. I was going to say, thank you.
So what is referred to by enhanced authentication is that a new packet, the so-called auth packet, was introduced with the MQTT 5 specification. So a typical handshake for an MQTT connection is the client sends a connect to the broker, and then the broker sends a connect acknowledgement to acknowledge the connection. And with MQTT 5, there's also the option to introduce additional auth packets. And this allows you to implement what is called challenge response types of authentication. So, what this brief explanation, right? So you define some sort of, let's call it secret, that lays outside of the client and outside of the server that needs is implemented in the security. So very easy example. It's for example, the secret is ×2, right? So then the client sends the server, hey, 3 is my number, and then the server asks the secret server, okay, what's the secret? Oh, it's ×2, and then the server responds with 6, and then the client also can check with the secret keeper if this is the correct calculation. In short, it just allows challenge response type, more secure authentication. I have to say here that from my experience, at least as it stands right now, this is not very well adapted yet. The strategies we talked about, like using a combination of TLS and JWT, for example, also provides a very secure communication. So it's important to say that while MQTT 5 has more options, it's absolutely fair to say that MQTT 3.1.1 is also very secure.
Thank you.
Can be
Florian.
Implemented very securely. Yes.
And by the way, what I was looking for was specific call out that we have around, the advanced authentication standards like SCRAM or Kerberos that we can now, implement because MQTT 5 allows for that. All right. So let's see, what else do we have here? Anything we missed from a security perspective, Jayashree, something you might have caught? I think we've answered everything here.
I mean, Raphael here has a question. Is it possible for didactical reasons to access Hive Broker over unsecured MQTT? I have only seen the elephant as I access Hive from unsecured friends like that. So if I interpret this correctly, the question is, so it's absolutely possible to allow unsecured over TCP connections to a HiveMQ broker. Of course, we would never advise to do so in production and in any deployment that is reachable via the public internet. And so, for example, our cloud-free offering, anybody here is invited to spin up their own HiveMQ cluster to test with for free on our managed service. And for that, we do by design not offer unsecure connectivity. But if you host your own HiveMQ broker or you run it locally on your machine, you can absolutely also use the unsecured TCP port for connectivity.
There is one more question on chat. So it's from
Badi asks if we believe TLS alone is enough, and I think this was sort of the main point Gaurav was trying to make from this presentation, is that TLS alone is not enough. So you definitely want a multi-layered security. Gaurav showed in one of the first slides that this multi-layer is multi-dimensional even, right? So it's not only the application layer, it's other layers as well. But even within each layer, you then want, again, multiple steps So yeah, I would always recommend adding authentication and authorization on top of TLS encryption. And like Gaurav mentioned, with HiveMQ, you are absolutely able to, from a client side, the client doesn't need to do anything other than sending a certificate, and then on the broker side, you can implement additional authentication authorization based on the contents of the certificate.
Thank you. And Kevin, I'm sorry, I think I missed your question on the Q&A part. So thank you for posting it here. I think I'm having to swap between two windows, so I might have missed it there. I will need to check back on this. Any news you have, Florian, on trusted execution environment support for IoT edge devices? And if that's on the roadmap, and I see it's ARM, Microsoft, and Scalus project, it looks like. So I don't have an instant answer for this, unless you know more.
I don't have an answer. So typically we would not be discussing roadmap items in this webinar in any case. So
yeah. So Kevin, I'll look it up a little further. Thank you for sharing the context, and I'll follow up if there's something there where we have an opinion, perhaps. Thank you for that. Is it possible? So Sauru is asking if it's possible to detect an authentication issue, authorization issue, encryption. So yeah, perhaps it would have been good to have a slide in there or two on the idea of integrity and seeing where is it that some information might have been changed. No, so Sauru, I think it's possible, right? Authentication wise, as we saw, there are response codes plus Boolean responses you get from the application itself to say pass, fail, and what you want to do next with it. Same idea with authorization. Now, I think what you're also saying is that if something has been modified, do we know? So it is possible. There are in the metadata itself, we can include information and checksum, etc. on specifically that. Again, more information is on the pages here. But Florian, anything you want to particularly point out here?
Yes, I do want to give my perspective on the questions, and as mentioned, I'm the head of support at HiveMQ, so I come in contact with all kinds of issues that our customers see, and from that perspective, HiveMQ definitely offers tools to detect such things. So we have log statements, we have metrics that count and show whenever a failed authentication happens, when a publish outside of an authorized topic happens, or when an SSL handshake fails. And these can definitely be leveraged and monitored to create some sort of alerting and warning system, to see if it's a hacking attack, or what's more realistically, just some rogue client that didn't have to be malicious as such, but just a wrong configuration, for example. And then HiveMQ has tools to help our users identify those and fix their system and their clients again.
Thank you, Florian. And I'm reading this question from Henry Sun from a subscriber perspective. Data pull push. Let's see. Just the essence of the question is: can I use MQTT to pass data from a low to a high security zone? And if it's compliant with the Purdue model? I mean, it's
so yes,
go ahead,
you definitely can use MQTT for that. I mean, so if we're talking about the Purdue model, which I'm not super intimately familiar with, but I know it comes from the OT-IT combination space, and bridging the air gap, as they say. And MQTT, or specifically HiveMQ, is used for that by our users. And specifically, we offer something that is called the Enterprise Bridge extension. So where you can basically chain multiple brokers together, and then you can go through different DMCs, different levels of security zones from brokers to brokers. So you would, for example, if you have a not so secure client wants to connect to the data that is sent by a very high security client, the high security client would connect to one MQTT broker, and then you would bridge the data to a second MQTT broker in a different security zone, and then the receiving client or subscriber in this case would then subscribe to that second broker, and that's how we can be able to work different security levels of networks together. And again, in the manufacturing space, this is a use case that's already been used in production by multiple of our customers.
Very good. Any final questions, anybody?
I mean, more if you're asking about a example project, I'm not sure exactly. Maybe if you reach out afterwards, then we can discuss more what you mean exactly. But we do have example security extensions and stuff like that for sure.
One more question, Q&A. As an OEM manufacturer, how do I secure or anonymize my client's data beyond segregation with topics?
I mean, there's certainly multiple ways, right? I mean, you could, Gaurav mentioned payload encryption, you know, could be done, for example, or we know, for example, that in a connected car use case, you have this sometimes where some of the data is personalized and you know, connects to the VIN of the vehicle, whereas other data is pseudonymized or anonymized. I don't know if those are actual English words, but and you know, for example, you then do some hashing over the client ID and could change it inside the topic, for example. But the most clear answer would be here some kind of encryption, right? So for example, what we see a popular solution is using a specific protobuf scheme where, you know, that also adds a level of security, because, you know, without knowing the appropriate scheme to decrypt it again, you couldn't even decrypt that data, for example.
Very cool. Jayashree, I think that's all the time we have. So back to you.
Yep, I think we have covered almost all the questions. So there is one comment from Anant Mishra. Maybe we could give him some tips. He's saying it's time to think about discussing within IT and OT team, enterprise and domain architectures. Maybe we can share a couple of tips with him. Florian?
I mean, so we've already mentioned, I think, the MQTT essentials, and then also we're talking about the OT space. There's a additional specification on top of MQTT. Spark plug, it's been mentioned before here. Question was, does HiveMQ support it? Definitely does. And we also have Spark plug essentials on our blog post. So this will probably be a good starting point. Also, you know, we have a number of customer stories on our website where some of our customers talk about what they do with HiveMQ, what value it provides to them. Could also be a good starting point. We have a community forum, community.hivemq.com, where I encourage everybody to join. And, you know, we have an MQTT section there where any questions can be answered, and both our community as well as my team and the engineers from the HiveMQ team will go there and answer.
I think we have covered all the questions. So this has been great. Thanks, Gaurav. Thanks, Florian.
Thank you, Florian.
Thanks, everyone, for attending.
Gaurav.
Absolutely.
Thanks, everybody.
Thank you, everyone, for attending. See you all in the next session. We will be sharing a follow-up email with the recording and the slides and a couple of links to all these resources we were talking about during the session. So see you all in the next session. Thanks again. Have a wonderful day. Bye-bye.